Well, here we are in C++ CallFort, which is a C++ file. It has a C++ extension here, you see. The first thing you notice is this extern capital C in double quotes and a bunch of stuff between a pair of parentheses. We are prototyping our functions here. These are the FORTRAN functions fun1 and sub1. You'll notice that names of the FORTRAN functions have to be in lowercase, and you have to add this trailing underscore to any FORTRAN function name or subroutine name. Anyway, fun1 and sub1 both take an argument which is a pointer to a float. Now, the difficulty is sub1 block and fun1 block, the two FORTRAN common statement. There's no equivalent really to a common statement in C or C++. However, in FORTRAN the common blocks just end up as blocks of binary with enough space for the data in it, and that's what happens with your structs. So we declare a struct is going to be called sub1 block, again all lowercase, just like fun1 and sub1 had to be, and with a trailing underscore, and it has a float beta in it just like before, except float is of course a 32-bit floating point number, just like a FORTRAN real, and the same thing goes for fun1 block. So this is how we deal with the two common blocks in the FORTRAN routines. So here we go. The usual thing with structs, you set beta equals to 1, but you actually have to put in the struct name with the trailing underscore and dot beta rather than just beta. Then we call sub1 with the address of alpha, and then call fun1 with the address of alpha. And let's see what happens. Well, before we see that, let's have a look at sub1. It has the common block sub1. We've changed absolutely nothing in sub1, and the same thing goes for fun1. And let's have a look at our makefile, C++ CallFort. There we go. We're compiling C++ CallFort, depending on C++ CallFort.o and the subroutines and the functions, and at the end we have -lg FORTRAN, which is a library which it will be able to pick up automatically. Linking with this library will tell the compiler what to do with those FORTRAN write statements. So the G++, when linked to this library, will understand them. And here we are, we have the instructions for C++ CallFort.o, which is just the usual -c -fpic. So we'll do make CallFort, and then, well, all this works absolutely fine. Everything does what it should do, and we've successfully called FORTRAN from C, or C++ in this case. So if we were going to write a C program that calls FORTRAN, what would we do? Well, we'd do exactly the same thing, except we delete the external C and begin parentheses, and of course we delete the bracket at the end. That will be how C calls it, and of course you'd use GCC instead of G++. So that's how you do it from C. It's as simple as that. Now what we're going to do is make our FORTRAN library from fun1, fun2, sub1. Going to look at parsing matrices later, but we're not parsing matrices at the moment. But we've put sub1 matrix.o as a FORTRAN routine into the library, libstat and libdyna. So I shall do make libdyna. So we have our libdyna dll.dll, and then we're going to do make C++ DLL by compiling C++ calls FORTRAN, usual -l dot -ldyna DLL. There it is. So make C++ DLL, and then C++ DLL. And here we are. We can see that everything is working fine. It's getting the data. Oh, I finally fixed these write statements so it tells you X and Y. And you can see that the data is getting in and it's getting out. There we are, gamma equals 322.5 at the end. So everything's worked fine. Calling it from C++, calling the DLL routines from C++ has successfully got the data in and successfully got the data out. Well, let's have a look at subroutine sub1 matrix. This is going to be given two things, A and X, and through sub1 matrix block, B and Y. Now, here we are, we're declaring A to be a 3 by 2 matrix and B to be a 2 by 3 matrix, and then we write out the matrix A that's arrived, the function argument, and write out the matrix B which has arrived here via a common block. Now let's have a look at our calling routine, C++ call matrix fort, and we have the usual extern C, and here we are, we're prototyping sub1 matrix, again all lowercase with the trailing underscore. Now you'll notice here that the struct sub1 matrix block has got a matrix, B matrix. Its dimensions are 3 and 2, not 2 and 3. The reason for this is the peculiarity. C and FORTRAN store matrix data a little bit differently. One as rows and columns, the other as columns and rows, which means that the B matrix, when you fill it in, has to be the transpose of the matrix B as it appears in the FORTRAN program. This is a weird thing, but there we are. The same thing goes for A matrix. It's 3 and 2 in the FORTRAN routine, and we have to put 2 and 3 for the transpose of the matrix in the FORTRAN routine. So we'll just fill up our matrices with 1, 2, 3, 4, 5, 6, and the same thing for E matrix. Again, it has to be sub1 matrix block, all lowercase with the underscore dot rather than just B matrix. And so we've filled the matrices and we write them out. And let's have a look in sub1 matrix. We'll just write out the matrices as they've arrived, and again we can check to see that what it's writing out is the transpose of the matrix that they're given. This isn't really any inconvenience when you're calling FORTRAN from C or C++. It's just something you have to remember, but it doesn't mean you have to do much in the way of extra work. So let's do make C++ call matrix fort. Again, it's got the -lg FORTRAN for use with G++, and then let's do C++ call matrix fort. Well, this is A matrix 1, 2, 3, 4, 5, 6 in the calling C++ routine, and here it is 1, 2, 3 in the first column, which was the first row, and 4, 5, 6, which is second column in the FORTRAN routine, and the second row in the C++ routine. And again, here we go. 7, 9, 11 is the first column in B matrix in the C++ routine. 7, 9, 11, and 8, 10, 12 is the second column, which now turns up as the second row in the FORTRAN routine. Apart from that, everything else is working just as it was before, and gamma's ending up at the correct value of 322.5. So what about the DLL? Oh, before I continue, notice this as well. You must declare in the same order as in the common block. So in the common block, double B the matrix B occurs as the first in the list, and beta occurs as the second in the list. So you've got to declare B matrix before beta in the sub 1 matrix block structure. Again, this is how the matrix gets passed. It's been given a pointer to a double. That's a 64-bit rather than a 32-bit float, and A matrix is declared like so, and B matrix is obviously declared in the structure. Now, what I've done is passed the address of the element 0, 0 of A matrix, which is just one way of doing these things, and the address of alpha, and then fun alpha. So that's the way we can pass our matrix to the FORTRAN function. B matrix is just declared in the normal way from the transpose bit. So anyway, now we have libdynadll.dll. We can now go and compile C++ DLL. So here we are, C++, call matrix fort DLL, depends on C++ call matrix fort.o, is G++ minus O. There we are, there's our executable name, just the object file for call matrix fort, link it to dynadll, and then the usual minus LG FORTRAN. So make C++ call matrix fort DLL. C++ call matrix fort DLL. And what do we have? 1, 2, 3, 4, 5, 6 in the FORTRAN program, and 7, 9, 11 is a column which turns up as the first row, and then the second column in B matrix in the C++ program turns up 8, 10, 12 as the second row, as before, and as before, gamma ends up as 322.5. So let's conclude with the fact that we can call FORTRAN routines and functions from a main C++ or a C program without very much of a problem at all. There are just a few key things to remember. What's more, there are plenty of resources out there if you do a quick Google on calling FORTRAN from C, C++, and the other way around. It's easy to find out how to do things like that. And more importantly, if we do call a FORTRAN function which is stuck in a DLL from C or C++, the data will get in and we can get the data out. And that includes two-dimensional arrays. No problem. We just have to remember that transpose thing.